How a battery works. This is Christina and that is Nabila, and today they're going to show you how a battery works. And the materials are a voltmeter, zinc metal, copper metal, a sodium nitrate salt bridge, sodium nitrate solution, copper sulfate solution, zinc sulfate solution, and a funnel, 2 beakers, and 4 pairs of crocodile head wires.
So the reaction here is a single replacement reaction, and it's a redox reaction, so electrons are moving. And we've created a closed circuit with our reaction, so the electron flows from the zinc metal to the copper metal. This is because the zinc more readily loses electrons than the copper metal. And the flow of electrons is obviously electricity. So zinc loses mass due to the electrons being released, and the copper gains mass because when the copper solution gains electrons, it's turned into a copper solid, and this attaches onto the current copper solid itself, creating more mass. And that is the reaction.
The procedure of this experiment: the first step is to sand down the metals, because metals often come with a coating that you need to remove in order for a reaction to occur. Then you're ready to set up the lab. First, set up the salt bridge by pouring sodium nitrate into a test tube and then sealing it with cotton. Then you put the metals, zinc and copper, into separate beakers, and then you pour solution zinc sulfate and copper sulfate into their respective beakers and put the salt bridge in between those beakers. Then you connect the metal to the voltmeter by using the crocodile head wires. You can interchange the positive and negative charge between the two metals. Then you wait for the electrons to travel across the wires, and then you take the voltage from the voltmeter and then you record. This is the sodium nitrate salt bridge that we built for the experiment. And then we placed zinc and copper metals into their 2 separate beakers. Afterwards, we poured zinc sulfate solution with zinc and copper sulfate solution with the copper. Then we placed the salt bridge in between the beakers to create a closed circuit so that the electrons can flow between the beakers. Finally, we attached the crocodile head wires from the metals to the voltmeter so that the voltage can be measured. And this is the completed setup. To collect extra data to make sure that a reaction actually occurred, you can mask copper and zinc before and after experiment to note any changes in their masses. According to the reaction, copper should be heavier after the experiment because solid was created from the solution, and zinc should be lighter because as zinc loses electrons, it becomes ionic and goes into the solution, so the zinc solid should lose mass. Here is zinc metal being masked after the experiment. And here's copper metal being masked after the experiment. As you can see on the voltmeter, something was wrong with our experiment because the voltmeter wasn't picking up any voltage or any electron flow between the metals. And this is a major error because without any voltage readings, our experiment proves nothing and it wouldn't be an experiment. So we had to think of another way in which we can measure the voltage that is occurring between zinc and copper. We decided that we had to switch our voltmeter to a computer program called Loggerbo that can pick up voltage and is more sensitive than the voltmeter. Hopefully, it would pick up the electron flow that is occurring between zinc and copper in their experiment. For our new setup, we had to use a new kind of wire that attached our metals to the Logger Pro machine that looked like this. Our new setup connected our metals to the machine, which is then connected to the computer that took our voltage readings. Luckily, the computer was sensitive enough to pick up the electron flow that was occurring in our experiment. The products of our experiment, besides the voltage readings, are solid metal copper, which was 0.038 grams heavier than the beginning of the experiment, but no color change as it is still brownish. And solid metal zinc, which is 0.069 grams lighter than before, and a slight blackish tinge to it that wasn't there in the beginning of the experiment.
In this experiment, we demonstrated how a simple battery works. However, for a real battery, a commercial battery, there's many environmental impacts. In a commercial battery, they use acids and alkaline solutions for the electrolytes. They use heavy metals for their electrodes, and these are all non-biodegradable and extremely toxic. Plus, they're single-use and they're incredibly leaky. So, animals can ingest these batteries and substances, and then humans can eat the animals. So then the toxins go from the batteries to the humans. Also, since the batteries are single-use, they're often dumped in huge landfills, and this creates lots of pollution. And since they're also leaky, there's lots of toxins in the area, which creates lots of environmental impact.